Welcome to PreMath. In this video, we have got this quadrilateral ABCD such that this angle A is 60 degrees, this angle B is 60 degrees as well, and this angle D is 150 degrees, and moreover, this side length AB is 2 times square root of 3, and this side length CD is square root of 3. And now we are going to find the area of this quadrilateral ABCD. Please don't forget to give a thumbs up and subscribe. And please keep in your mind that this figure may not be 100% true to the scale. So let's go ahead and get started with the solution. And here's our very first step. Let's focus on this quadrilateral ABCD, and we know that the sum of the angles in this quadrilateral are equal to 360 degrees. Let's go ahead and add all these three angles first. So when we add these angles, 60 degrees plus 60 degrees once again plus 150 degrees, that is going to add up to 270 degrees. So that means in order to make 360 degrees, this angle has got to be 90 degrees. So therefore this angle BCD turns out to be 90 degrees, as you can see over here. And here's our next step. We are going to draw some auxiliary lines. So therefore we are going to extend these lines AD and BC. Let's go ahead and extend these lines BC all the way over here, and likewise this AD over here as well, such that they meet each other at point E. And here's our nicer looking diagram, and as a result we got this triangle CDE. And now in this next step, let's focus on this big triangle ABE. And we know that the sum of the angles in this triangle must be 180 degrees. This angle is 60 degrees. This angle is 60 degrees. So therefore this angle has got to be 60 degrees as well. So therefore this angle E turns out to be 60 degrees. And therefore this triangle ABE is an equilateral triangle. And moreover, let's focus on this straight angle, which is 180 degrees. Since this angle is 150 degrees, so therefore this angle has got to be 30 degrees. So therefore this angle CDE turns out to be 30 degrees. And now let's focus on this triangle CDE once again. And in this triangle, this angle CED is 60 degrees. This angle DCE is 90 degrees, this angle. And finally this angle CDE is 30 degrees. So therefore this triangle CDE is a special 30, 60, 90 triangle. And here I have copied down this triangle CDE, and as we can see, our smallest angle is 30 degrees. So the side that is opposite to that smallest degree is going to be our shortest leg, and our largest angle is 90 degrees. So the side opposite to that one is going to be our longest leg. So therefore in such kind of special 30, 60, 90 triangle, always remember that the longest leg is twice as much as the shortest leg. And if we use a Pythagorean theorem, then this side CD is going to be square root of 3. So therefore our side length EC is going to be 1. Side length DE equals to 2, and this side length CD is going to be square root of 3. And here's our next step. Let's focus on this big triangle ABE, and we know that this is an equilateral triangle. So let's recall the area of equilateral triangle formula. And here's the area of an equilateral triangle formula. Area equals to square root of 3 times a square divided by 4, where our a value is 2 times square root of 3. Now let's go ahead and calculate the area of this triangle ABE by just replacing this A by 2 times square root of 3. Let's go ahead and do that thing. Area equals to square root of 3 times 2 times square root of 3 whole square divided by 4. And now let's go ahead and simplify this thing. We have a square root of 3 outside, and when we take a square of this one, 2 square is 4. 4 times this square and square root cancel each other out, so we got times 3 divided by 4, and that means our area is going to be equal to 4 goes into 12 3 times, so that's going to give us 3 times square root of 3. So this is the area of this triangle ABE. So thus the area of this big triangle ABE turns out to be 3 times square root of 3. And now let's focus on this triangle CDE, and we know this is a right triangle. Now let's recall the area of a triangle formula, and here's our area of a triangle formula: a half time base times height. And we know our base is square root of 3 and our height is 1. Let's go ahead and fill in the blanks. So area of this triangle is going to be a half time base is square root of 3 times height is 1. So area turns out to be a square root of 3 divided by 2. So therefore the area of this triangle CDE turns out to be square root of 3 divided by 2. And here's our final step. Now let's go ahead and calculate the area of this quadrilateral ABCD, and we know that this is going to be equal to the area of this big triangle ABE minus the area of this smaller triangle CDE. And we know that the area of this big triangle is 3 times square root of 3, and the area of this smaller triangle CDE is square root of 3 divided by 2. So let's go ahead and fill in the blanks. So the area of this quadrilateral ABCD is going to be 3 times square root of 3 minus square root of 3 divided by 2. And in this next step, this square root of 3 is in common, so I factored out. We ended up with 3 minus 1 over 2 inside this parenthesis. So therefore the area of this quadrilateral ABCD is going to be simply 5 times square root of 3 divided by 2. So thus the area of this quadrilateral ABCD turns out to be a 5 times square root of 3 divided by 2 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.